Now, another model is called the non-interference model. And this model is based on those security domains or execution domains or process domains that we described earlier. Remember, the domain is the collection of all objects that a subject has access to. And the non-interference model says that if a subject is accessing an object in his domain, that modification of his objects can in no way affect your objects. So, the non-interference model says whatever they're doing over there, it cannot affect what you're doing over here. So to summarize, a user's actions in one security domain cannot affect or interfere with users in another security domain. Now, if we're talking about the lattice structure, then a specific example could be a subject cannot be influenced by the behavior of other subjects at higher security levels. In other words, their information can't interfere with my information, and mine cannot interfere with theirs as well. But we also may look at this in another arena where we aren't necessarily in the lattice. Whatever I have access to, whatever I'm doing to my information, cannot affect the integrity of your information. So here we're going to start to delineate a little further, or perhaps once again, the lattice-based access control model. And let's keep this in mind. This is typically used with mandatory access control models, again used on military and government networks and information systems because of its very, very rigid level of security and its very, very high cost. It describes an upper bound and a lower bound. What do we just say? Layers or lattice that this model delineates. And it will then identify a label for a subject, a clearance label for subjects, and a classification label for the objects. When these two labels align, in other words, you're a top secret guy looking at top secret data, information can flow. Other examples of how this model works, as we see in the diagram here, in the slide here. Confidential information can flow to an object or subject that is working at the same level. In this case, the class of secret, the layer called secret. In another example, we might say that information can flow from a lower layer to a higher layer. This would be more of a confidentiality model because what they know down there, I'm allowed to know up here. So they can send information up. I can't send information down though. That would violate confidentiality. So that's a second example of how this lattice-based access control model might work. Again, these are just examples. I'm not defining anything about the way information flows within that model, other than these are some examples of how we might set up the rules to allow that information to flow. So with the lattice model, every pair of elements, that's a subject and an object, has a label, and it is delineated by an upper bound and a lower bound. This defines your layer in this lattice. And we combine the clearance and the need to know labels with the classification and category labels of the object, and when they align, information can flow. So in this example, again, this is just another example, we have a subject named Kathy who has a top secret clearance and a need to know for Iraq and Korea. Well, as Kathy attempts to access content, an object named file B, and confidentiality is my concern, because file B lives at a secret layer rather than the top secret layer, for confidentiality reasons, Kathy, the subject, is allowed to access the object. For confidentiality as a concern, I'm allowed to read lower layer content, but I'm not allowed to write to that lower layer, because if top secret writes to secret, we might be divulging confidential information. So again, Kathy would be allowed to read file B, but would not be allowed to write to file B. And again, this is only the example where our concern is confidentiality. This, of course, would violate integrity rules. Kathy would be allowed to write to file B for integrity rules.